Okay, I'm going to talk about this project we have this is an OREI funded project last year to develop cultivars for organic systems and train new plant breeders, and I'll explain the interaction. But listed here are the people that were on the grant to begin with. I'm the director of the Plant Breeding Center at UC Davis, and I'm also an alfalfa breeder. So I'm not actually breeding the vegetables in here yet. I might start a spinach project, but anyway. Raul and Carol and Mark are at the student farm in the Ag Sustainability Institute at Davis, where we'll be doing a lot of work. Jorge's a graduate student who had started doing some breeding that was part of the reason I got interested in developing this project in the first place. And he also works with Paul Gepps, who's the bean breeder. Dina St. Clair's the tomato breeder. Alan Van Dyne's the pepper breeder. And then Jared is our connection to the organic seed folks in California. But so these are the folks on the grant, but there's a whole bunch of other people involved. And so Amanda, who's here, is a program rep with the Plant Breeding Center, and Margaret Lloyd is a cooperative extension specialist in Yolo County and a couple counties around Yolo, where UC Davis is, working on small farms and organic production. And then the rest of these are, I think, all the rest of them are graduate students at UC Davis in plant breeding who are all interested in getting involved in some aspect of this project. So we've had a lot of interest from students who really want to know something about field-based breeding, and particularly breeding in organic systems. So it's been very, very heartening, I guess. Here's one of the students in her bean field. Okay, so when I was hired at the Plant Breeding Center, we had sort of three main goals. One is that we need to improve our graduate education, and particularly around field-based breeding and getting students trained in field-based breeding methods and just know-how, so they can go out to breeding industry or academic positions and know something about cultivar development. I'm very interested in having public plant breeders develop something that's useful. So releasing cultivars that have some commercial interest. And so one of the issues we always have as public breeders is that, well, there's a corn industry out there, we're not going to release corn hybrids and so on. So where are the niches that we can fit in the public sector to release something that's useful and at the same time train students? So I think those go hand in hand. And then the third thing that we work on is developing new technologies to enhance breeding efficiency. And I would say of these three, this is one that's most easily funded externally through competitive grants and so on. And so really, thinking about how do we get students out there with hands-on breeding experience, and how do we release something that's useful? And so I think that working through the organic, with the organic sector is one area where we can bring these two together. And of course, any new technologies we have, so DNA markers, for instance, for disease resistances, can feed right into that program. Okay, so just a little bit more about improved germplasm, and I'll show this is Kyle Qualsett, who some of you may know, who's I think he's in his mid-80s now, still releasing varieties from UC Davis. This was a couple years ago up in Northern California at Tule Lake, and Cal is sort of the old guard of breeders who did do cultivar development. They had a cultivar development program, and most of the students got involved in it. And they were funded through the experiment stations, and those funds have more or less dried up. Cal's just doing this on his own now, I think. Oops. So, what we would like to do then is to develop and commercialize germplasm, cultivars, and in the process of doing that, train students. And to the extent that we can partner with seed companies. So this is in general, not just organic, but certainly organic is one place where we can play, I think. Partner with seed companies, develop something that's useful, complementing what's being done in the commercial seed industry, and including participatory breeding, so breeding or evaluation on farm, to the extent it's warranted, and working with the organic community, are ways that we can really do all these things in a world where we have a seed industry for some of the major crops. So that led to this grant, which is an experiential learning-based public plant breeding pipeline for organic cultivar development. Okay, that's quite a mouthful. But so this is what we propose to do. So developing cultivars and having the graduate students actually organize the programs and conduct the work. So rather than just have them doing something that their major professor tells them to do, this would actually be set up so that the students drive the process. So we are working with the student farm to do the breeding in organic land, and then also work with the organic community to do on-farm trialing, and to work with the organic community to get the ideas and to help the students figure out what they might want to prioritize for traits and cultivar concepts, if you want to think of it that way. So it's really something that would get the students right into it. They will be running the process, and I'll talk a little bit more about how that's going to play out. Now, interestingly, just last week we had a Women in Plant Breeding forum at Davis, which was very well attended. We have a number of women throughout, from graduate students through, fairly high up in some of the major seed companies, talking about what they saw in the seed industry and so on. One of the people that was talking said, one thing that's very important for breeders in general, not just women, but breeders in general, is to get hands-on experience. And if graduate students can get hands-on experience in breeding programs while they're working on their degree, it would be very advantageous. I said, well, that's exactly what we're trying to do here. So that's something from the industry they see, and we've heard this, of course, many times. They see a need for students to have that training. Oops. Okay, Kathleen. Kathleen told me at dinner last night that I had to talk about G by E. So I want to talk a little bit about breeding for organic systems before we go on. Do you need to breed specifically for organic systems or not? And I don't really want to get into that in too much detail, but certainly there's potential for genotype by environment interaction. So you have different organic systems are different from conventional systems. There may be different disease profiles and so on. And I think this was what Jeff was talking about earlier. So in some cases maybe not, but in other cases maybe so. So if you want to breed for trait X, you might have to do it in organic systems to get a cultivar that performs well. But I think beyond just that, though, there's also different market niches. There's the need for different, especially when you talk about vegetables. There's a lot of different opportunities to develop vegetables that have market opportunities, and they can be bred in organic systems because they're going to be grown in organic systems, and so that makes sense to do it that way. And one of the things that we have often heard from organic farmers and others too is the unavailability of OP cultivars where they can't save the seed and so on. So to develop cultivars that are open pollinated or where the seed can be saved is something that would be useful, and that's what we're going to try to do through this project, at least initially. Okay, so the proposal that we put in really is to develop this pipeline and kind of develop a sort of infrastructure so we can plug additional breeding programs in over time. And the way it's set up is that I'm the project director, and we're going to have a half-time master's level person who sort of coordinates and keeps everyone going, making sure the projects are being advanced. And there'll be a number of breeding objectives. I'll talk about them in a second. There'll be a faculty advisor, but the advisor is advisory. It's not, the faculty aren't leading the project. The students, there'll be a primary student that will be on a part-time graduate assistantship. So in addition to their actual thesis research, they could be involved in this breeding project that may or may not be part of their thesis. But it'll be an actual project. They'll be leading it, have other graduate students who are interested participating with them, and as well as undergraduates from the student farm who are interested in breeding, seed saving, these types of things, being involved in each of these projects. So the goal really is to have this student, so for some time while they're a graduate student, they'll be in charge of the project, and as they graduate, maybe one of these other students moves into that position and takes over, and hope, if it works well, we'll see how well that works. We should have some continuity in the project, and we can get, drive toward cultivars. Now, The organic farm is very important over here because that's where the first phase of research will be done before we move out on farm, and then on farm in the organic community through Jared, through Matthew Dillon at Cliff Bar, and then with various seed growers and organic farmers that we've been talking with, participate both in developing these objectives and in working with the students and on evaluation and so on. Okay. Oh, so just to point out that this position has just been advertised as of yesterday, right? Yesterday, Mark. So if you know of anybody who might be interested, talk to me or Mark or Amanda, and we'll see what we can do. So, proposed breeding project. So initially, about a year ago, actually, we met with some organic seed growers, a meeting that Jared had put together over in Sacramento, and talked about some of their interests. And so you go around a room full of farmers and you get about a zillion different things that everyone's interested in, you know, and a million crops and different traits, and, you know, it's almost impossible to try to consolidate that down. So what we're focusing on are the crops that we have expertise in-house, the faculty have expertise working on, which are beans, peppers, and tomatoes for now. And this can potentially grow as time goes on. But to propose something to begin with, this is where we're at. So there's two projects in beans. One on lima bean, which is on ligas tolerance. It's actually a project that's been going on for some time, and they're at this point ready to take some advanced breeding lines into on-farm trials. So this is something where we can start getting on-farm trials set up and develop that sort of infrastructure, if you want to look at it that way. There's another common bean project that's really just introgressing resistance to bean common mosaic virus into heirloom beans and into other cultivars. And this is something Paul Gepps had started a couple years ago, and through this project we can accelerate that. So this is a simple, a single gene, and there are good genetic markers for it. So this will be a genetic marker-based backcrossing project into heirlooms to give virus resistance. In pepper, there are two projects that are underway with Jorge Burney, the student I mentioned at the beginning. He was interested in developing some larger jalapenos that have more larger cavity size for the popper market, which I don't think is a very big market, but a market that he was interested in at any rate. Another, and something that's of more interest to the growers, is sun scald resistance in peppers, and so they have some crosses already started on that. So the bean projects are the farthest along. The pepper projects have some crosses that have been made, and they've started some things. There's a sort of a team of students that's been working together. And then the tomato project, that Dina St. Clair, who's the tomato breeder, is very interested in getting something going, but they haven't defined their goals. They have a number of different possibilities from different types of cherry tomatoes to nematode resistance and other things. But depending on a survey that we've sent out to some participating growers and seed folks, we'll decide what route they're going to take. So that project is really just in its infancy. So back in November, we had an initial meeting of the students, the faculty on the project, and folks from the organic community, including there's Jared back there, and this is at Davis, to start talking about the project, talking about what we're proposing for projects and whether they thought it was a good idea or not, and you know how we could move forward. And I think it was a very exciting meeting, and I think, at least for me, it went very well. So this is the first of many, and again, we're trying to, we want to involve the organic community early on in the project to make sure that we're doing things that they want. I mean, there's no point in me doing this if no one cares. One of the things that came out at that meeting was that we really should survey other organic participants who weren't able to attend about these common bean, lima bean, pepper, and tomato projects. What are they interested in? What would they like to see out of these? And this survey's out right now. I think it closes in another week or so, at the end of the month. And so this, particularly for the tomato project, this is very important. And for the other ones, it's going to help us identify what other traits we need to develop into those varieties. Well, there's Mark and Raul talking to us about the student farm. I think the student farm is an important component of this grant for a couple of reasons. One is it has organic land, and so we want to do all the breeding in organic systems, and this is organic system land. It's right on campus, so it's fantastic from that standpoint. But it's also sort of a nucleating site where we have the graduate students can be working together with a lot of undergraduates who work at the farm and do various things, so they can participate in these breeding programs. And then probably a third thing is that a lot of school kids come through here, and there's a lot of tours that come through the student farm, so we can raise awareness among the next generation of plant breeders, get them clued into what's going on with breeding, and maybe getting folks excited from an early age about different varieties, about how much diversity you might have in a program, and so on. So from an education standpoint, and then from a practical breeding standpoint, the student farm is a key component. So here's the pepper team. I mentioned there, Jorge sort of, he's a graduate student working on beans, but he's had this pepper project on the side that he just started for the heck of it, as well as various other little projects in breeding that he started on the side. I don't think his advisor knows he has all this stuff going on. But anyway, he's managed to convince several other students to work with him, and so this is sort of a nucleus of the grant. Really, they've been doing this for a couple years. Where this is some crosses or some seeds they planted in the greenhouse. Here's some progenies from last year, some crosses that they had, and so on. So, the key now is to sort of, make this all a systematic process of breeding. Have a kind of clear plan going out where they're going to go. What's the concept? What are the traits they need to get into a final cultivar, and so on. And so that's what they're working on, as well as the other groups. Well, a key point of this, as I've been saying, is graduate student training. So this is Sarah Doley, who works for Paul Gepps in her lima bean field. So these are part of the project that she's working on, as part of this grant. So organizing field days and presenting at field days will be important in this project, and we expect all the students to be involved in those, either at the student farm or on organic farm or inorganic farms where there might be trialing varieties and so on. So there's good extension opportunities, Kathleen, for these students. And again, on-farm evaluation and testing. Okay, so I mentioned earlier, about we have these students moving through, and so there needs to be some way to track what's going on in the breeding program. I think this is going to be, this might be the trickiest part of the whole thing, is trying to manage the program and making sure things don't fall between the cracks and so on. Well, we're considering a couple of options, but the one I'm particularly leaning toward right now is this integrated breeding platform that's being developed by CIMMYT and the CG centers are using, and also various other people are using it as well. It's still under development, and there's still some gaps in it, but it's a way to manage germplasm, develop crossing plans, develop plot plans to put out things in the field, track your seed room inventory and things like that. We need to have some sort of tracking mechanism. So when one student graduates and another takes on, the information is all going to be stored somewhere, and it could be accessible. So we're looking into this, and hopefully we'll make a decision this spring as to whether this is what we want to go with. But we'll try to do something that will be consistent and will enable us to keep the history and tracking of the project going. So the next steps, we need to finalize the initial projects of each crop. We need to develop the plans, and so this is what I want the students to start thinking about it in their teams is, what's your season by season approach? Where are you going, and what are you expecting to have to do each season? And then get stuff going in the field and with organic producers as it makes sense, especially with that lima bean project. So I want to thank the OREI project. So this is, we have to put, and there's the standard information that the U.S. government may not agree with me. But so the question is whether, say, new technologies, marker-assisted breeding and things have a downside. Are there downsides that get lost in the shuffle? Well, I think it kind of depends. It's context dependent. Like this bean thing, the goal is to get the resistance gene into a bunch of heirlooms, because without it, they're sung. So I think that's pretty straightforward. I don't think there's any real downside to it, other than the fact that you're moving in the same, chromosome segment into everything where you have that resistance gene, and maybe there's something associated with it that's, susceptible to another disease or something. But so you always have those kinds of things. But that would happen whether you're doing markers or not. So, I don't really think there's a downside to markers, particularly if you can identify markers. Maybe some of the other, it's more obvious how you could potentially come up with problems with some of the other technologies. But I think it's context dependent, and looking what your goals are, seeing if that's going to move you down the road faster, and there's no obvious reasons not to do it, then I would say go for it.
Some of that's been really oversold too, right?
Oh yeah, well, there's no doubt about that.
Yeah.
The question is, how do we take the whole farming system into account in our breeding? Well, and so the problem. So if everyone has a different system, there's no way you can really breed for every system. So you have to have one, and hopefully that it's reasonably representative of what most people are doing. And so, so we're working with at the organic farm, and in the rotation system that they have, and with their cover crops and so on. And I think that's something else that will come out with the survey and with further discussions with the organic growers as to what's the consensus system, or what's the best idea that they might have, and the way we should do it. I mean, it's not something we're ignoring at all, but it's also difficult to try to get everybody's system represented. Yeah. So the comment is that markers tend to focus on traits that can be identified and where markers can be used, and that might not be the most important trait. So I fully agree, and that's. I've also heard people say, well, we can't phenotype this trait, so markers are going to be really useful. Well, if you can't phenotype it, well, you're out of luck. So.
You generate a lot of information with genomes.
That's right.
Whether it's useful or not is another question. Okay, moving on. Thanks, Charlie.